Let me introduce our first speaker. Lajos Papp co-founded Sequence IQ in early 2014. He's the organizer of the Docker Budapest meetup and co-organizes Kubernetes meetup. He is a self-employed technical trainer. The title of his talk, Kubernetes Virtual Clusters. Please welcome to the stage, Lajos Papp.
Hi, welcome everybody. Please, if you can switch on to my laptop. Maybe we have to do something. Okay, it's the usual. Let's try to switch screens. Okay. Maybe I plug it out and plug it in again. Although it's not Windows, but usually it helps. Okay. Yep. Okay, so this is my talk, Virtual Clusters. And as you can see from my T-shirt as well, this is all Kubernetes-related talk. And I will split it up into two parts. First, I will talk about what is virtual clusters. And in the second part, you will have a chance to do some exercises. Okay, so once we do the exercises, you can come forward to the tables and open your laptop, and we will do exercises together if you want. So first, I will try to talk about what virtual clusters are. Okay, we will solve somehow the issue. Maybe I have to plug it in again. What do you think? Igen, kihúztam, bedugtam. Okay, let's hope for it's working. So, let's just start it. I was already introduced, so I can skip this part, but if you need it, okay, I shouldn't touch anything. Seems like there's some connection issue. What do you think we should do? Because this one is a problem. Should I use an HDMI converter? Would it be better? Oh, actually it is. Okay, so without you seeing the slides, I can start to talk about virtual clusters. And what is it all about? So first of all, let's do the morning exercise. Please, hands up who is already using Kubernetes. That's a good one. Okay, who is using Kubernetes in production? Okay, so quite a lot of hands. So now the problem what we are trying to solve is that a lot of times you have different environments, like you have your development environment, QA, test, or sometimes you have even more than one environment for different customers, okay? So usually you can make them separated from each other by using Kubernetes namespaces, right? So you can use just one single big cluster and split it up into namespaces. Now this one is a decent solution, and it's built in Kubernetes, but it has a couple of issues with it. If you are sharing one big cluster, then of course the administrator or the operator has to create role-based access control for each of the resources. So you have to set up security in a way that is feasible. If you think about, like, you would have like two customers, and you are deploying the same application for the two customers, and you want to separate them even more than just one namespace, then in Kubernetes, there's not a built-in way to do that. So usually you will end up creating a lot of small Kubernetes clusters. But if you are creating a lot of small Kubernetes clusters, then you have yet another problem. You have to manage them. And usually what happens is that you are wasting resources, because most of the time you are trying to sort of like oversize the Kubernetes cluster so that it can fit all the load that you are imagining your application will have. And once you have a lot of clusters, then you will oversize all of them, and at the end you are just wasting resources. A couple of other issues where you could use virtual clusters is, let's say, and again the exercise, who is using a public cloud provider for running Kubernetes? Okay, so it was probably half of the Kubernetes users. Then who is using on-prem? Yeah, even less. So when you are using an on-prem Kubernetes, you have full control which version you are using, how do you configure, and everything. But if you are going to a cloud provider, it's much easier to manage because you are just clicking on a nice web UI, and here you go, you have a 10-node Kubernetes cluster, but you don't have access to all the configuration, what you can change in a Kubernetes cluster. For example, one of them is Kubernetes version. Right now, if you are using, let's say, GKA, the latest version what you can use is 1.21, which is actually like 3 minor versions behind the latest version. So, okay, so okay, cable. So it wasn't DNS, it was just the cable. Oh, I shouldn't raise my right hand, so it was still. You know what? Maybe it's sleeping. You know what? Maybe I should set that it never sleeps, the display, right? Help me. Where can I set it? Oh, actually, that's true. There is a command for that one, caffeinate. Okay. Just caffeinate? Okay. Maybe that one is. Okay, let's do it in a different terminal. Okay. Timeout. Okay, anyway. Let's hope it helps. Okay, so somebody please count the seconds. So if it's like after 30 seconds it disappears, then it's still a problem. So the third one is role-based access control. As I already mentioned, when you have one huge cluster, usually what you are doing is you give one namespace for each of the developer groups or each of the environment, and you set role-based access so that the developer can only create any resources inside of that single namespace. Now, but what happens if the developer has a task that he has to create some custom resources, or he has to create some cluster-wide objects? Now the problem is that he doesn't have any such a role. If you are using a virtual cluster, what you can do is create a small virtual cluster inside of your namespace where you are administrator. So you will have cluster-wide access even inside of one namespace. So from the host cluster point of view, you are just using one namespace with a lot of strangely named pods, but for yourself, there will be a completely separated cluster. Okay, and the last one is, it's a really interesting one. A lot of times what happens is that you are deploying a lot of application into your Kubernetes cluster, probably with Helm, and after a while, you just realize that you are running out of resources because all those pods are consuming memory and CPU, even if they are not even running. So one feature what you can do with a virtual cluster is you can pause it. What it means is that all your resources are still existing in the API server, but what you are doing is you just decrease all the replica sets for all workloads down to 0. So that way, you are not reusing any resources, and once you need it, you can scale it up again. Okay? So these are a couple of reasons to use it. Okay, so now this is the architecture of how virtual cluster is working. So basically what you can see here down is the host cluster. So this is, let's say, the GKA cluster. You got access from the corporate operator, and you have access only to one single namespace. You cannot create anything else, just a couple of pods, services, and ingress in one namespace. Now what you can create is, look at the, let's say, on the top left, namespace 1. It's telling that it's running, actually it's just one pod, one single pod. Virtual cluster is running in a pod with 2 containers. One container is running, let's say, Kubernetes control plan, or more concretely, it's just an API server, and then there is a synchronizer. So now the trick is that it's not a full-blown Kubernetes cluster. It does everything except running the pods. Okay, so if we think about who is responsible in the Kubernetes architecture for getting the pods up and running? Who is responsible for getting the pods up and running? Sorry? Kubelet, after somebody decided that a pod belongs to a kubelet. Yeah? The scheduler. So the trick is that we have a control plan without a scheduler. Okay? So what happens is that you have an API server with controller manager, with etcd, with everything, but without a scheduler. And what the synchronizer does, it will take all the pods from the virtual cluster and will copy them into the host cluster into your namespace. The only thing will be all those pods running inside of your virtual cluster will have a strange name in the host cluster. So look on the right-hand side. For example, the pod 1 in the namespace 2 in a virtual cluster will be named like pod 1-1-x and a lot of dashes. Usually an X in the middle, which you can imagine like sort of like a separator between the cluster name and all the other ones. Okay, so actually when I was telling that it's running API server and the etcd, I was lying because etcd is not running there. What they do is they run a really small Kubernetes distribution in one single container called K3S. Have you ever heard of K3S? Who has ever heard of K3S? Hands up. So K3S, we are using K8S for abbreviation for Kubernetes because K and S has 8 letters in between, so Kubernetes. So K3S is less than Kubernetes, with a lot less K3S. So at the beginning, what K3S was, at that time, there was still the company Rancher, which is already acquired by SUSE. And the head developer, Darren Shepherd, just was playing around like, oh, how could we create an easy Kubernetes distribution specifically for the edge use cases? Edge means, in that case, that I want to run Kubernetes everywhere. So even if you are a phone provider or you have a huge windmill company, you want to run Kubernetes everywhere. So even on small devices which have limited CPU and limited memory. So they figured out like, okay, how can we make a really small lightweight resource usage Kubernetes distribution? And what they did a couple of tricks. First of all, they created a single binary. So if you want to use K3s, all you have to do is download the K3s binary, and it just works. If you want to, have you ever installed Kubernetes on a clean Linux machine? Well, it's a bit more complicated than that, right? If you ever read the nice guide from Kelsey, of course, there is no talk without mentioning Kelsey. The Kubernetes the hard way, it's quite a lot of steps. You have to install a lot of things on the operating system, then you have to install a container runtime, Docker or Containerd, and then you have to start a bunch of components, apiserver+etcd, and so on, configure them all together. Now, what you are doing is you download K3s, you type K3s server, and that's it. You have a running Kubernetes cluster. Now there is one cheat that instead of using etcd, they decided that etcd is hard to use, hard to maintain. If you think about like how can you save the state of a Kubernetes cluster, because API server is stateless itself, everything is stored in etcd, basically it boils down that you have to back up your etcd. Now the question is, do you know how to back up an etcd? And usually you are probably not familiar with it because you probably never used it outside of Kubernetes. So if you think about like, yeah, most of the time when I'm using my own persistence application, where do I want to store my persistence data? In a relational database. So the crazy or the genius idea was behind that replace etcd with a relational database. So what Darren did was wrapping around, at the very beginning, it was just SQLite, and wrapping around so that from outside it seems like etcd, but it's not. Okay? So you have a built-in storage. It's not etcd, it's SQLite, but later they developed like a plugin system, and you can use your own data store. So you can use MySQL, Postgres, whatever you want. And then you have a persistent storage for your Kubernetes without taking care of etcd. And actually, it's not a fork. It's just a less than 100 lines, less than 1,000 lines on top of a real Kubernetes cluster. You can even go to the GitHub repository, and you can see, so this is the repository of the Kubernetes version K3s is using under the hood, and you can see that this one, the bottom one, is the actual commit from the Kubernetes source code. So you can see that there are something like 20, 30 commits on top of Kubernetes. So at the beginning, when it was just a proof of concept, it was really like deleting a lot of things from source code and a lot of crazy stuff. But right now, it's really nothing else, just 30 commit on top of Kubernetes. OK, so let's make it full screen again. All right, so this is how K3s works. Now you can see that although you have all the components like API server here in the middle, you have the kubeproxy, you have the controller manager, you have the scheduler, but it's all one single process. Okay? So it will be less resource usage in terms of memory and CPU, and that's why they created the single binary. And here on the left-hand side, you can see KINE, which is an abbreviation of like GNU. GNU is not Unix. Kine is not etcd. So that's the abbreviation. So this is the part where they replaced etcd with something. OK, so all what we have to know about K3S, that it's a really lightweight Kubernetes distribution specifically created for edge use cases, but you can use it completely for everything. And virtual cluster is using K3S under the hood. So if I go back to this picture, what really happens is that inside of that namespace, actually it's here, the vCluster control plan on the bottom left page, bottom left box, that's where K3S is running. OK, so what were the design principles behind virtual cluster? It should be lightweight with low overhead. So what it means that when you are creating virtual clusters on a hosting cluster, you don't want to waste, yet again, resources, because that was in the first place to solve the problem of resource waste. And because they are using K3S in one single pod in a container, that it will use really just a few resources. Now the second one is they didn't want it to have performance degradation. What do we mean by that one? We know that the workload at the end, the pods, are still running on the host virtual or the host Kubernetes cluster. So that means that if you are running something, a deployment on the host cluster or inside of the virtual cluster, from outside is the same. Okay? It's just a pod running on the cluster. So there will be no penalty in network usage or CPU usage, memory usage, nothing like that. OK, the next one is reduced request on the host cluster. That's that is an interesting one. A lot of times what happens if you have one huge cluster and you have a lot of application, that sometimes the API server will have a lot of communication. If you have ever written like an operator that you know that most of the components are connecting to the API server and getting events, getting messages from the API server. And once you have a lot of components, there will be a lot of messages. And basically, like, you get a lot of messages which you are not interested in it. And with virtual clusters, what you can do is you can sort of like get only the messages which are really relevant for your workload in your virtual cluster. Okay? So you can separate even the API server communication. Okay, the next one is no admin privileges required. That is a really important one. So if you want to use virtual cluster, basically, if you can run a pod, that's all what you need. So you don't have to ask your administrator, please give me some special role-based access control so that I create something. No, if you can create one single pod, you're good to go. Single namespace encapsulation. So this is really trying to mimic the same separation what people use in a naive way, that let's say you are using one namespace for the QA environment, one namespace for the pre-production, and one namespace for production. Why do we like namespaces? Because you can set resource limits, you can delete them all together with one command. And therefore, the design decision was that when you are creating a virtual cluster, all the pods running in that virtual cluster will be in one namespace. Okay? So you can do the same resource limitation, you can delete the whole cluster by deleting one namespace. Easy provisioning. Now, of course, when you try to use something on top of Kubernetes, normally you are just doing Helm install and you have it. although Helm, you can use Helm to install virtual cluster, they created specifically a command line interface called vcluster, so you can use that one. But they are interchangeable because basically when you are using vcluster, like for example creating a cluster, vcluster create cluster is the same like issuing a Helm command, but you don't have to know where is the repository, what are the default values, how to do. You can do it even with customize or with plain kubectl commands. And all these ways of provisioning virtual cluster, they are interchangeable. I will just demonstrate it. And easy cleanup, it's already told. OK, so now a couple of words about networking. Of course, it's always the question about the DNS. In this case, the issue with the slides wasn't DNS, but otherwise, you have a lot of times issues with DNS. Now the question is, what happens with the DNS inside of the virtual cluster? If you think about, I was telling that when you are running a workload, let's say a deployment inside of the virtual cluster, all the pods will be running on the host cluster. Okay, so when you think about pod-to-pod communication, it's already solved because we already know that all of the pods running in a virtual cluster, they will be pods in the same namespace. So with pod IP, they can communicate with each other quite easily. Now the question is, what happens with services? Now, what happens with services that the synchronizer, the syncer, will also take care of copying the services from the virtual cluster to the host cluster. The same trick like renaming them and slightly changing them, but they will appear in the host namespace as well. But now it's important to mention that inside of the virtual cluster, you have your own DNS resolver, because inside of your virtual cluster, usually you want to reach only the services running in your virtual cluster and not the services running on the host. Okay? And therefore, we have our own DNS inside of the virtual cluster. Okay, some additional features, I already mentioned it. The scale to zero, that's a really useful one. So for example, what you can do is you can prepare, let's say, a demonstration by deploying your application, which maybe involves a lot of different Helm charts. And once you are ready with that one, you see that, oh, this is using a lot of resources. I don't need it today. I will need it tomorrow when I'm doing the demo. What can I do? I don't want to do the whole setup tomorrow again because it takes like a lot of time. What you can do is create a virtual cluster, create all the demo environment in the virtual cluster, and then scale it down to zero. So it doesn't use any resources. And the next day, what you can do is just resume from the pause state, the cluster, and then everything works like you tested it the day before. The syncer has a default setting about which resources to copy from the virtual cluster to the hosting cluster. But of course, you can configure it however you want. For example, the default way the syncer works is when you are creating an ingress inside of your virtual cluster, the ingress will be copied to the external, to the hosting cluster. So even if you don't have an ingress controller in your virtual cluster, you are still able to create ingresses. Why is it important? Because, yeah, when you want to use ingresses, always the first question is like, OK, which ingress controller do I want to use? Now, again, tell me which ingress controller are you using? Nginx, yeah. Who is using Nginx? Yeah, probably most of the people. Any other?
Istio,
Envoy, yeah. What else? Traffic, yeah, exactly. So probably these are the three mostly used one. And what it means that what you can do is you can create your own virtual cluster, and you can even play around with your own Ingress controller. Let's say you want to try out, oh, I read that traffic can do some features for you which Nginx cannot, or the other way around. Now what you can do is create a virtual cluster, and for the syncer you can tell, oh, you know what, don't sync the Ingress resources, I want to handle them myself, and then your responsibility is that you can choose a different Ingress controller which is running on the hosting cluster, and you can play around with that one. Or maybe you want to use a different version of the Nginx Ingress controller, or a different version of Envoy. Or maybe you want to use istio, but only for one specific application, and you have no rights to install istio on the hosting cluster. And since the last version of vCluster, there is also a way that you can extend vCluster for custom resources. And you can do that via plugins. So basically what you can do is you can create your own syncer, and you can write this code in Golang or whatever language you want to do. Basically, it's something like a controller, like an operator. So it's probably around the same complexity. And 3 example plugins, what they are doing. One is custom CRD synchronization. So for example, if your application is using custom resources which you would like to be copied to the external, the hosting cluster, you can use that plugin. Or sometimes it's more interesting that you want to have something copied the other way around, copied from the hosting cluster inside of your virtual cluster. Let's say, for example, that you are using some private image registries. When you are using private image registries, you need some pool secrets, okay? So, for example, your operator already configured the hosting virtual cluster to have all these credentials to talk to your private corporate image registry. Now, if you are creating a virtual cluster, how can you communicate to the same private registry? Easy. You can just use this image pool secret plugin. What it will do is, whenever you create a new virtual cluster, this image pool secret will be copied from the hosting cluster inside of the virtual cluster. And now one step further on abstraction, you can auto-deploy something, let's say a deployment. You always want to make sure that whenever you create a new virtual cluster, it's not empty. You already have some deployment in it, whatever it will be. That's the auto-deployment plugin. Okay, and now the demo, although what we can do is, I have 10 minutes from the first part, so maybe I'm opening up for questions. If you already have questions, please raise your hand. Or do we have a mic? Or, yeah, the mic is coming.
Hi. I have a question. How would you solve when you have istio running on the host and you have a gateway, and then every team on their own namespaces create a virtual service connecting to that gateway, and that's how they go out to the edge? And how would you reference that gateway from inside that virtual clusters?
So maybe what I would do is don't install istio on the hosting cluster, but use your own version inside of the virtual cluster, because then you don't have to do any synchronization issues. Otherwise, you have the problem what I just described, that you want to have, let's say, your istio custom resources be copied outside to the hosting cluster. I would avoid that and do it the other way around, that run my own istio. Of course, that means that I will use all those resources for istio, for each virtual cluster, but you can use a different version, because that's also a lot of times comes around, that different projects want to use a different version of istio or a different configuration.
Mm-hmm. But then also a lot of more management for each namespace to keep their own.
Yeah,
istio
absolutely.
installations.
It always comes about management, and it's also important to mention that usually you shouldn't do something like helm install, but instead use some sort of automation called GitOps, and use some of the well-known GitOps tools to do all this type of management. So it's probably, yeah, we'll use resources, but you shouldn't do that manually.
And one more question: how would you reference like other namespace services in other namespaces from the virtual cluster?
Inside of the virtual cluster?
Yes, yes.
Inside of the virtual cluster?
No, like another other virtual cluster, pods running on another virtual cluster, and the service. So DNS, how would that resolve that?
Okay, so that's a tricky one. Even if we are just talking about how can you reach a service running on the host cluster, but that's possible. You just have to configure the syncer that it will sync some or all of the services from the host to the virtual cluster. So there will be services readable inside of the cluster. But if you think about the network level, all you need is just a DNS resolution to pod IPs. And because your pods are running on the same cluster, right, like the host cluster, pods will be able to communicate to each other by pod IP. So there will be, by default, no restriction. If somebody would ask, but what if I want to have some network separation between virtual clusters? That's also possible. When you are creating the virtual clusters, you can configure it that when you are creating the virtual cluster, you, by default, you can create network policies so that one virtual cluster cannot talk to any other services, only running in the same virtual cluster. So by default, it's open, easy to use, but if you want, you can restrict network communication inside of one virtual cluster. Of course, for that one to work, the hosting cluster has to provide network policies. Any other questions?
You mentioned there's some minimal resource overhead for running K3S, additionally to your, whatever your Kubernetes is. Do you have any specific numbers on just how much that resource overhead is, other than small?
It's really small, but to be more specific, you can run it even on a Raspberry Pi. So one thing that they are creating ARM images for K3S, therefore for virtual cluster. So it's using like, I think, I have to look it up, but if it's running on a Raspberry Pi, then it should be less than 1 gigabyte of memory usage. So it's quite small.
Good, thanks.
Any other question?
So is there any version dependency, like a host Kubernetes cluster can run different Kubernetes versions in the virtual clusters, or multiple different versions maybe?
Good point, yeah. For example, one of the demos I can show. You know what? I'm just showing you the exact setup. So what do we have here? I'm running a 9-node Kubernetes cluster on Google, okay? So if I want to see like which version do I use here, I go to this terminal, and if I do kubectl get nodes, I can see that it's using version 1.21.11. Okay, so this is the latest I can get from Google. But what happens if I want to use 1.24? Now what I was doing here, I have created a virtual cluster with a different API version. Why? Why can I do that? Because the K3S has a lot of different versions. So what I can do in my virtual cluster, I can use an API server with a different version. So look, inside of my virtual cluster, if I do kubectl get nodes, I can see it is using version 1.24. So I'm using a different version than the hosting cluster. And from the hosting cluster, all I see is, if I do a vCluster list, how many virtual clusters I have, I can see that there is a vCluster 1241, 124.1. This is a virtual cluster, and I'm using a different version. And to configure that one, it's quite easy. If I can find this one. Yeah. So this was the configuration for creating this virtual cluster. Maybe I can make a little bit bigger font. So all I had to do is define that I want to use 1.24. Okay? And I can run even more than one with different minor version, different major version, and so on. I can even go backwards. So if I have a 2 new host cluster, I can go back to a previous one, which is more stable, for example. Okay, any other question? Yep. Could you please pass around the mic?
Here.
Okay.
How nodes are assigned to these virtual clusters? So for example, if we have a use case like we need a special CPU or a special GPU or a special memory capacity, how can these be defined or selected?
Yeah, good point. And you can see that right now I'm using, let's go back to the virtual cluster, and if I do a kubectl get node, then you can see that it just seems like one node. Why? Because by default, the virtual cluster is just faking the nodes, and you only see the nodes which are actually have some workloads on it. So this is by default. It's just using fake nodes. But if you want to change, of course, you can do that. Let me grab the documentation. So it's vCluster. And if you go to nodes, then you can see that there are 3 different types of how do you want to use nodes. Maybe I make it a little bit bigger. So the default one is faking the nodes, or you can say use the real nodes all, and what is the last one? Oh, use nodes with label selector. So basically, you can configure a virtual cluster so that it sees all the nodes from the host cluster, and then you can use all different types of, how do you name them, affinity, anti-affinity, taints, everything, and it will take into account all the labels on the host cluster nodes. Okay? Yep.
So I assume that if you have these virtual clusters, then you run all your workloads on actually those. So you are actually using K3S instead of a real Kubernetes distribution. Is there any disadvantages for that, like performance or not having a real etcd?
As we said, once the pods are running, they will be synchronized out to the hosting cluster. So, okay, you know what? Let's just do a demo. This is what I did here. So here on the screen 1, I'm showing that, let's say, I'm developer 1, and I don't have full access to the whole cluster, okay? So if I want to do like kubectl get services in all namespaces, oops, I have role-based access control that I can see only services, deployments, and everything only in my user 1 namespace. So look, what I can do is kubectl get all, and I see that I don't have any workloads. Now what I did, I was creating a virtual cluster in a different namespace. Let's see that namespace. So look at this one. kubectl get all in the namespace, and I'm using user1-play for the virtual cluster. And look at this one. You can see that, if you can see, that there are a couple of pods running here. And look, this is a launch, a pod called launch. You can see here in the middle, it has an X. And this is probably the identifier of the Helm, which I used. And this is the namespace, and inside of the namespace, the pod. Now I can show you in this terminal, if I do a kubectl get nodes, this is my own virtual cluster. Look, it is 121 version, so it's a different one like the before, the 124. And if I do a kubectl get all, in all namespaces, now suddenly I have admin access. I'm using the same user like before, but if I'm trying to talk to the hosting cluster, look at this one in console 1, kubectl get pod in all namespaces. I don't have any access to that, but right now I'm talking to the GKA cluster with 9 nodes. Now if I switch back to the virtual cluster, which I was creating in my own namespace, now I'm an administrator. So if I do, for example, like Helm list, I can see that there is a Helm chart deployed here. And even if I kubectl get all, I can see that there is a pod, a deployment, and there is also an ingress. It's still inside of the virtual cluster. But if I'm using the ingress, it's synchronized to the external cluster, so it just works. And look, inside of the virtual cluster, kubectl get namespaces, I don't even have the Nginx ingress controller deployed. So I'm saving resources again, because I don't have to create an ingress controller for all my virtual clusters. So that's quite usual. If you want to save resources, don't create it for each virtual cluster. Use it from the host cluster. And if I go back, so here if I'm asking for pods, you can see that there is one pod called launch chart whatsoever. And if I go to the host, kubectl get pods, in the namespace called user1-play, that I can see this is the pod I'm using. And what is the 2 other pods? This VC user1, this is my API server, and I also have my own DNS. Okay? So that's all what I have as a virtual cluster. Any other question? Okay, if there are no more questions, what I would suggest is that now you can get your hands on my cluster, and let's get started and type something. So if you have a laptop and you want to do the exercises, please go to the tables, and I have prepared something like 25 sessions. So maybe you can pair up with somebody. 10. Okay, so we can use 20 sessions for the table, and we still have like 4 remaining. So if somebody has no place at the table, still can do it. Just let me know. So if you want to do the exercise, open your laptop and sit at a table, or pair up with somebody. So what we will do is, we have this huge cluster, and what you can do is, you can create your own virtual cluster, and what we can do is play on those virtual clusters as full administrators. Okay? So first what you can do is, all you need is just a browser, and in your browser, go to a session, and each session has its own URL, userx.kubernetes.eu. And so who is doing the exercises? You can do it from your phone. All you need is just a browser. So okay, you can use it you can use the user one. Who is using?
We need to use different letters for.
Yeah, different numbers. So you can use user 2. You want to have one?
No thanks.
You want to use one? Okay, use user 3. Anybody else? You can use 4. You want to use? Okay, so if you go to that URL, let's say I'm playing with user 11, then first what you will see is it will bring up a role-based access, a basic authentication, and the username for everybody is user. Okay, and the secret is, let me show you, is this string. Okay, so SZ1KR3T. Okay, so user name is user for everybody, and this is the password. And if you are successfully writing it, you should see a black screen with access to the cluster, right? Okay, so now if you type, like, for example, kubectl get node, then you will see the same nodes like on the host cluster, and you will see the same 8 nodes, or 8 plus 1 nodes. Let me know if you can't access it. So kubectl get node, and you should see the same 8 nodes. Okay, so now the fictional company, Kubernetes.eu, has a namespace for each of your developers. Okay, so if you using that session, and I'm switching to user 0, which is this one. So if I do kubectl get all, I can see that in my namespace, you can see the namespace here, user 0 namespace. I do not have anything here running. Okay. So what we will do now is just create a deployment and create also an ingress so we can see something in the browser. Now you can imagine that if we want to deploy something, what we will do is use Helm. Helm is already installed in these sessions. So what we will do is just use a Helm command to create a deployment. I created a Helm chart for being able to use a small application which is configurable. Now to do that, actually, if you want to type less, you can cheat because I created some helper script. So look, for example, if I'm typing echo hello. Now if you type hint, you can see my last command. So if you just type hint, and you can see what was my last command. And you can even say you want to see my 5 last commands. Then you can see what was the 5 last commands. And if you are really, really lazy, then you can even let the terminal copy and paste the last command for you. All I have to do is, if I'm issuing a command like echo, I am really lazy. All I have to do is I save this command for you. Now, if you are just typing lazy, you will execute my last command. If you want, you can type the command, or you just have to type lazy, and then you will execute my command. Okay, so now we are ready to create our first deployment. And what we will do is use a Helm chart I just mentioned. So 12 factor. So this is a 12-factor application. And what you can do is just use two environment variables or two Helm variables, title and color, and it will deploy an Nginx and create an index HTML with that title and with the background color. So to be able to use that Helm repository, we have to install this one. So look, what I can do is I can install the Helm plugin and add my repository in one line. And now if I'm typing ZZ, all you have to do is type lazy, and you will have my repository. So if you do a Helm repo, Helm repo ls, you should see my 12-factor repository. Are you able to reach it? Let me see. If you type lazy, just type lazy. OK, so now we are installing that one. And now if you do Helm repo ls again, OK, now you have it. OK, just use the URL, let's say user5.k8z.eu. OK. And username is user. And password is secret with 1 and 3. So SZ1 S1 KR3T. Yeah. OK. And now if you type lazy, then you will have the same repository. OK, now you can do, after a couple of seconds, Helm repo ls. Helm. Now you have the repository. Cool. Is it also working on the phone? Wow. OK, now once we have the repository, what you can do is create a customized Nginx application with an Ingress. So what we will do now is just use this instruction. So what it creates a Helm release called lunch with title lunchtime, and color is medium purple. OK, I just run this command. And I save it to you, so you can just type lazy, and you will have the same Helm release. So now if I do a Helm ls, I can see that there is a new Helm release called lunch. So just type lazy, and you should have the same Helm. And now if I'm looking for ingresses, there will be some ingress here, and I can copy and paste that URL. And it is working. It is a real ingress with a real domain name. So you should have the same text. Yeah?
Okay, it's already installed.
Yes, and if you type kubectl get ingress, yeah, OK. It's really small, but if you type SVS, you will have a clickable. So, yeah, just SVS, yeah.
OK, thanks.
And here you go. OK, do you have the?
Yeah, I got it.
Show me. OK, and now because you are using the browser terminal, you can just type CVS, which is like service, SVS, sorry, yeah? Yeah. S, sorry, S. Yeah. Yeah, that one. And now you can click here, and it will open up in a new terminal. And it opened up, yeah? Check. Okay, you have it. And nice. Now the next exercise, change the color. All you have to do is just run the same Helm upgrade command and change the color, or even change the title. So I just go back to the upgrade command, and let's say I'm using the color, and now it's really important that I use some nice colors. So I will use salmon, but you can use something whatever you want. So color should be salmon, and the title is CraftConf 2022. Okay. So now what happened is I'm created a second revision of the same Helm chart. And if I go back to here, look, now it's a different color with different text. Okay. So far, what we are doing, we are using a shared cluster. Each of our developer has its own namespace, and we are creating deployments, pods, ingresses in our namespace. Up to that point, you are still able to do the same stuff. We haven't used virtual cluster yet. Were you able to, change something? If you just go up and try to, yeah, you have to copy and paste that command, the upgrade command, and change, let's say, the color, yeah? Oh, nice. Okay, were you able to? Yeah. Okay.
Just a few, I got the orange, but I don't know.
Okay. So now what we will do is, let's imagine that we want to use something which should be deployed on cluster-wide. Okay, so for example, let's say we want to use policy enforcement. Do you know what is the concept of policy enforcement? Sorry? It could mean a lot of things. If you go to the CNCF landscape, then it will be part of the security and compliance. I think that's the name. Yes, security and compliance. And there are a lot of tools here. And I would just mention two of the mostly used one, the OPA, Open Policy Agent, which is quite complex. It has its own domain-specific language to declare policies, but an easier one to use is the Kyverno, which is just a simple YAMLs. And what you can do is you can enforce in your cluster some best practices. What of the best practices you want to enforce? Let's say you already learned about, for example, readiness probes and liveness probes. Do you use readiness probes in your deployment? Yes, you should. And probably you already told to other developers, like, hey, make sure that you have a readiness probe because it's really important. But what happens if a developer tries to create a deployment without a readiness probe? Nothing. He is not compliant. He did not create the readiness probe, and it will be still working. Now what these policy agents can do, they can implement a validating or modifying admission controller, and they can sit in the middle of the API server, and they can check, oh, somebody wants to create a deployment without a readiness probe? No. And you have two choices. Either let the deployment be created and just take a note of it, or just refuse the creation. Okay, let's say we want to introduce that into our development workflow, but we are really afraid that, oh, if we are deploying it to the hosting cluster, maybe somebody will fail to deploy something. Therefore, what we want to do is just create a virtual cluster for ourselves, play around with Kyverno, let's see how it works, and once we are happy with it, we can then implement the same on the host cluster. Okay. So first of all, if we check how can we install Kyverno, then if we go to the Kyverno web page, it will say get started, and to install Kyverno, this is the only command what you need: kubectl create and a huge YAML. Look what happens if I'm trying to use that command with my restricted user. I don't have access to that one because I need cluster level access. I don't have access to that one. Now, finally, I can use virtual clusters, create a virtual cluster for myself, and install Kyverno into my virtual cluster. Okay, now how can I create a virtual cluster? Of course, as I said, there are 3-4 different ways. I could use Helm, I could use kubectl, customize, but the easiest is probably if we are using the vcluster command line interface. To do that, first we have to install it. So all what we have to do is go to the vcluster quick start, and look, it's just 2 commands to install some command line tool, and we are using Linux and AMD. So this is the 2 commands, and again, just to make your life easier, what I will do is I will download the binary and move it to the path. Oh, sorry, yeah, I didn't copy the correct one. So, ooh. Oh, I don't need sudo because I'm already root. So that's the single command. I can just save it for you. So now all you have to do is type lazy, and now you are installing vcluster, the command line tool. So now what you will be able to do is do a vcluster version command, and it will tell that, okay, right now you already have the latest version 0.8 for vcluster command line tool. Okay, now how can we create a virtual cluster for ourselves? Look, it's quite obvious we will use the create new virtual cluster command. So all we have to do is vcluster create, and all we have to say, and let's show the help. Oops, where am I? So you have to give it a name, and you have to say which namespace to create it. Now, so that we are not creating the virtual cluster with the same name, what we will do is use a prefix like user 0, 1, 2, 3. You don't have to remember which one you are using because there is always an environment variable called ns. So I will create a command which you can, again, lazily copy and paste. So what I will do is virtual cluster create, and the name of the virtual cluster will be vcluster dash and the name of the namespace. Okay, and I want to use the namespace I am right now. So it will be the namespace. And what else? I want to expose it so that the virtual cluster can be reached also from externally. And I think that's it. So I was pressing enter, and now I can save it. Oops, sorry. So now you can just type lazy, and you will create a virtual cluster. And look what happened is now that in the same namespace, I already started my application. Now we can see that we have a stateful set called virtual cluster, and this is my API server. Okay, so it's a stateful set. And now if I want to talk to this API server, I have to get a kubeconfig for that virtual cluster. And to be able to do that, all we have to do is virtual cluster. I think there is also a list command, but I have to say the namespace that in this namespace, and now it's telling that it's already created in 1 minute. And now if I want to get the kubeconfig for this one, all I have to do is look the vcluster connect command. So vcluster, and I can say connect to vcluster dash my namespace in my namespace. Okay, so look what happened now, that it created a local file called kubeconfig YAML, and this one is the kubeconfig for the virtual cluster. So right now, I'm still, if I do a kubectl get node, I'm still talking to the host cluster. If I want to switch to that one, I just have to set the kubeconfig environment variable to ./kubeconfig. And now if I do a kubectl get node, I'm talking to the virtual cluster. I would like to see that you are able to create the virtual cluster and able to talk to that one. Were you able? Cool. Okay, yeah, you are able. Okay. Now, this is our own virtual cluster, and we have full admin access to that one. Look at this one. We can even check, like, what are the namespaces. So look, kubectl get namespaces. Now I'm getting the namespaces from my new cluster. So, and you can see it's the usual empty cluster. I don't have any of those pre-created namespace like on the host one. So this is an empty one. Even if I do a kubectl get pod in all namespaces, look, inside of my virtual cluster, there is just a DNS running. If I'm looking for, let's say, all the services, kubectl get services in all namespace, again, I don't see anything other than the API server and the DNS. Okay, so now we have our own virtual cluster. Now let's try to deploy Kyverno into that virtual cluster. So now I go back to the Kyverno installation quick start, and now I'm copying this command, and now it is just working. Okay, so now I was able to create Kyverno. So I saved the command for you. You can just type lazy. And now if we check for namespaces, as usual, this Helm chart is installing itself into its own namespace. And now we can see that the Kyverno namespace has been created. And if we are looking into that one, oops, kubectl get all in the namespace Kyverno, then we can see that there is a pod, and this pod is running the policy enforcement admission controller. Okay? So now we have already the admission controller up and running. Now what we can do is we have to create policies. And look, with Kyverno, it's quite similar to Istio. When you want to use Istio, you have to create Istio custom resources. If you want to use Kyverno, you have to create the Kyverno custom resources. Even if we are asking around kubectl get custom resources, now we can see that in our virtual cluster, now we have a lot of Kyverno related custom resources. The most important one is the cluster policies. Now, if I'm trying to get cluster policies, I don't have any. Okay? So I install the admission controller, but I don't have any policies. Okay, let's start to use some policies. It's really easy because Kyverno is kind enough that they just collected a lot of policies ready to use. And look, they even collected it into different categories. And if I go to best practices, I can see what are the default best practices policies. So for example, one I was mentioning is that the probes required pod probes. So look at this one. I make it a little bit bigger, and we can see this is a cluster policy. Okay? And now, without reading any documentation, let's try to understand what it does. Do you remember when we went to the CNCF landscape? The other well-known policy enforcement tool was the OPA, Open Policy Agent. Open Policy Agent is quite complicated to use. You have to learn a domain-specific language, okay? So it's on. Now if you look at this one, oh, that's just YAML, and you can see validate. You have the validate message, like liveness and readiness probes are required, and look at this one. Yeah, I'm too close, but it is checking pods, okay? So it's matching pods. And all it is trying to do is go into each container and check that the liveness probe is greater than 0. So this is the only thing which we have to understand, this simple expression that it's bigger than 0. Okay? Why is it working? Because what is the default value? So even if you are creating a readiness probe with all the default values, I think the period second default is 10 seconds, right? And of course, it doesn't make sense to create a readiness probe with 0 period seconds, so this is a really easy check. Now, look at this one. If we want to use this one, then all we have to do is, look, they're providing us a YAML file, and look, if I'm creating this one, oh, that's just a URL. So all I have to do is kubectl apply -f and create the policy. Okay, so now if I'm asking for cluster policies, now I can see that there is one. Oh, sorry. Let me just. So now you can just type lazy, and you will have the same cluster policy. And look, what happens is that now we already have this policy up and running, but the only thing is it's ready, but action is audit. You remember I said you have two choices, either just auditing or enforcing. So right now the policy is there, but we are not enforcing it. Look at this one. I can try to create a new pod, so something like kubectl run, I don't know, Delmi, and I'm telling that I want to use the image Nginx. And look, it tells me that the deployment has been created, kubectl get all, and the pod is in creating state, and probably after a couple of seconds, it is running. Okay, so somewhere there is a report. I don't want to go into too much details into how Kyverno works. Later, if we want, we can go. But now what I want to do is change this rule. Instead of just auditing, change it to something more strict. And what can you write here? Again, if you think about like kubectl get cluster policies, and look, if you want to get all the details about what can you write into the specification, do you know what is the command? You can get the help for a specific resource about the specification. Maybe you have used the explain. So you can just tell kubectl explain cluster policies .spec, and you will see what was the name? Validation failure action. Validation failure action, and look, you can choose between either audit or enforce, and the default is audit. So look, now what I want to do is just patch this one. So maybe what I can do is just do a quick edit on the cluster policy. Again, what was the name? Yeah. Okay, and now we go to spec. Oops. Oh, VI is not liking. What was it? Audit, right? So now I can check it to enforce. Okay, and now if I want to make it available for you, what I can do is kubectl patch cluster policy. And this was the name, and the patch is just change the validation to enforce. Okay, now you can type lazy, and you will change it to the same one. And now what happens if I try to create a new deployment? Wow, look at this one. I'm getting an error message that the following policies are not followed, and there is a description, liveness and readiness probes are required. Okay, so just to sum up what we did, instead of messing around on the hosting cluster where we don't have any roles to install Kyverno, what we did, we just created our own specific virtual cluster. We installed Kyverno there. We installed some custom policies, and we also played around enforcing it. Imagine if you would do the same on the host cluster. Now, everybody who is trying to create a deployment without a readiness probe will fail. And what you can do is, let's say you start to introduce policies. Let's say you start with the QA environment, and in the QA environment, you are just using audition. Okay, so you can say like, oh, okay, on QA, you can do whatever you want. I just want to have audit. But on production, you probably want to do really enforcing those policies. And there are a lot of policies. Now you can imagine, instead of using Kyverno, which was like a one-line command to install and a one-line command to create a policy, we could do the same with, let's say, install istio into our virtual cluster. Or if we were reading about which service mesh to use, then we probably have heard about that. If you want to have less headache, then instead of istio, just use linkerd2, And then you can even play around, like create a virtual cluster for Istio and create a virtual cluster for Linkerd and play around side by side, which you would not be able to do on a real cluster side by side because they are trying to achieve the same stuff. We still have something like, I think, 20 minutes. Yeah. So I'm open about which direction to go, which exercise you would like to create. We can try to create a new API version, because this one, even the virtual cluster is, if we are checking it, it's version 121. Maybe we want to use a more recent version. That's one thing we could do. Or if you want to play.
Is it possible to use an older version?
Sorry?
So if you have a new cluster and you are ready, you want to go forward, you're using namespaces already. You might want to use an older version. Is it supported? So if you want to run a 1.16 or something like that?
Sorry, I didn't get it. Can you repeat the question?
Sure. So the question is, so you have that cluster which is running one Kubernetes.
Sorry, let's wait for the plane because it doesn't have. I don't even hear.
So currently you are running on a newer Kubernetes version, so 120 something.
Yeah.
And you want to use an older version because for compatibility reasons, and so you want to go forward, but the teams who's actually using the cluster is not ready to move. And can you start an older version?
Older version. Okay, let's do that one. Okay. So basically what we want to do is, let's say you want to have a 1.16. That's old enough, right? That's stable. So let's create a server which is 1.16. Okay, so how can we do that one? If you remember the create command, if I can vcluster create, and if I do a -- help, then you can see that there are two different configurations which you can use. One is you can just say the K3S image to use. In that way, you can use any of the K3 pre-built images, but you are not even restricted to use K3S. There is somewhere, yeah, here is the list. You can use, instead of K3S, K0S, which is just a shameless copy of K3S. They don't acknowledge it. Or the vanilla Kubernetes distribution, or EKS. Okay? Just because I have tried this one. Okay, you know what? Let's do two things together. We already have our virtual cluster. No, let's create a different one. Okay, sorry. Okay, so if we want to create a new one, all we have to do is use this command. What was it? K3S image. It is deprecated, but you know what? Let's try it anyway. If it will not work, then we will use the values YAML, but I think we can use this one. So we are creating a vcluster, let's call it VC old. Okay, and we should use a different namespace. So we can use the play namespace because each user got two namespace and namespace play. Yes, and let's use the K3S image. And now I have to figure out what was the name of it. And yeah. So it will be, oops. Let me re-establish the connection. Okay, so 1.16. I'm not sure which one is the. So I can ask for image tags by the command line tool reg. So reg tags launcher.kubernetes and grep for 116. Okay, 116.9, that's the latest. Let's use this image. So if I go back to here, no, sorry, it wasn't that, was not the full name. K3S colon. Okay. It's deprecated, but it's still doing. So now I can save this command, so you can just type lazy, and you will have the same one. And now, if I'm checking for this virtual cluster, what I can do is virtual cluster list in the namespace. What was it? Play. Dash. Okay, it's up and running. Now what I have to do is get the configuration. So what I have to do is vcluster connect to this cluster, which is deployed into the nsplay namespace. Okay, so it's probably pulling the image. Or if I want to see what's happening there, kubectl get all in that namespace. Oh, it has a crash loop back off. Okay, so that's probably a too old one. You know what? We can ask what happens there. So kubectl describe the pod. Oops. Oh. Readiness probe failed, but it's pulling image 116. Okay. It's not able to start. Of course, this is like the live demo. Maybe 116 is too old, but you know what? How about creating something a little bit newer? Let's say 180. Should work. 116 as well. Okay, so 116. Instead of 116, just use 180. Okay, so I come back to here, create a virtual cluster old. Sorry, 18. What was the name? Dash 18, right. Container creating, so probably it's pulling the image. Let's wait for the pods. Oh, okay, running. It's almost ready. We need one more readiness probe. Okay. Crash loop back off. I like that one. Okay, you know what? I give up. It should work. There is some reason it's not working. I guess if I would spend a couple of minutes, I would be able to check it. Maybe what I can do is to show the pause feature. I think that one is quite useful. So, if I remember correctly, yeah, in virtual cluster 1, I already deployed something. And yeah, that was the launch one, right? Okay, so kubectl get ingress. So this one, this deployment, which is lunchtime, is deployed into my virtual cluster, okay? Now what I would like to do is pause this virtual cluster, and what I want to see is that this ingress won't work anymore, and once I resume, it will work again. So I go back to this terminal, because this is user 1, and if I ask for virtual clusters, vcluster list in the namespace user1-play, I can see that the VC user1, and now what I can do is VC cluster pause VC user1. And look what happens. It checks for all workloads, stateful set, deployments, even single pods, and will scale down all of them to 0. If they are just simple pods, it will be deleted. So look at this one. Right now, the pod is not running. I don't consume any resources. But if we check into the namespace, kubectl get all, into the namespace user0/play, the API server user1. The API server is still running there. Is it? Yeah, it just scaled down to 0. And also the deployment is also scaled down. Name, service, where is my deployment? Okay, anyway. And the same way, where I was doing pause, I can just do, what was the command? Resume. Oops. Okay. So now what will happen? kubectl get all in the play namespace. The API server is scaling up again, and it still takes a couple of minutes probably. Okay, yeah, and container is creating. It's not ready yet. Okay, it's running. So here we go. I was able to pause the whole cluster, don't consume any resources, and then resume and get back into a working state again. Okay, so we still have something like 5 more minutes. So if you have any remaining question, just go ahead.
How portable is the virtual cluster? So if I'm running it on my machine, I want to run it somewhere else, can I save it and right there? Or?
Yeah, good point. Like, okay, now if I created a virtual cluster, how can I take it with me? Now the question, we already described, like, where is the whole state of Kubernetes is stored? In etcd, but we don't have etcd right now. What do we have now? Sorry? We have right now SQLite. But what you could do is, let's say I'm at a cloud provider, at GKA, and if I want to, because right now, even if we think about this virtual cluster is not permanent, right? Because if I just recreate the whole cluster, oh, I have to create the whole stuff again. What could be the solution? Instead of using SQLite, I could use a relational database from the cloud provider. So something which is completely outside of my Kubernetes cluster. So for example, at AWS, I will use RDS. On Google, how is it called? Google Cloud SQL. I'm not sure if Cloud SQL is supported with K3S, but otherwise you are just creating it outside of the cluster. And in that way, all of your state is stored inside of an external database. And you can back it up the same way like you are backing up. Okay, so that way all your resources, all your Kubernetes state is saved. The only thing which is not saved, if you have stateful sets, where is the state stored? And usually there is a description in the V cluster documentation, and they say if you want to save the storage, then it's somewhere, Velero, I think the software is called Velero. Let me look for it. It's a backup solution, completely independent from vCluster. Yeah, backing up vCluster. There's the full description about how to use it, but basically they are selling like, use whatever tool you are using anyway to backing up your Kubernetes cluster. And one way is use Velero. If you want to save stateful sets as well, if you care only about the resources, then it's easy. Actually, turning back to, we said like, okay, what you can do is use anything other than SQLite, and then the whole cluster state is stored somewhere in an external database. But even SQLite is a good choice, because I just realized that it's not so lately that there is a new project called, and now I have to look for it, SQLite, yeah, this is it, lightstream.io. What is lightstream.io? SQLite, the way it works, you know, it just stores everything in one single file. And to do that, it's using the write-ahead log. So it's just writing into a vol file, and then periodically it just commits it to somewhere. And the Lightstream, this project, is written by none other but the guy who has created some, I forgot, one of the production scale database system. And he was writing this Lightstream. So what it does, it's a process which is connecting to the SQLite file and doing periodically backup into any S3 compatible storage. So what you can do is use a really cheap S3 storage and backup your SQLite. I was already playing with it, and what I was able to do is put an extra sidecar container into the API server and automatically back up my virtual cluster into S3 for cents. That way, of course, stateful sets are still losing its state, but all other than that, I can just save it for really, really cheap price. Okay. It's end of the time. If you have a question, yeah?
So I have a question about, are virtual Kubernetes clusters restricted compared to normal Kubernetes clusters in terms of what can I change in them, in what components? For example, I want to test a new Kubernetes scheduler. Can I spin up different virtual clusters with different schedulers?
Okay, actually, that's two questions in one. Can you change? Yes, and that's the good point, because, for example, if you are running on GKA, look, the nice thing is that I was creating this cluster in this morning just by clicking on the UI, give me a big cluster. Okay, I got a cluster, but what can I change in GKA on the master node? Nothing. I don't even have access to the master node. Okay, I'm not even paying for it. I'm just paying for the worker nodes, which is fine. But I cannot change anything on the master nodes. For example, I cannot change any API server configuration, right? I don't have access to that one. You can change all of these with the API server. For example, if you think about like, okay, right now I'm using authentication, the built-in one, which I get from GKA. Can I use the GKA cluster? And if I want to do authentication or authorization with my corporate LDAP, can I do that? Not really, because the API server I don't have access to that one. If I'm creating a virtual cluster, the virtual cluster API server can be changed so that it does the authentication with my own corporate LDAP. So I can just create an LDAP, a virtual cluster, and all the corporate users can use it right away. Wow, that's a good one. Now the bad news, the only thing you cannot change is the scheduler. Because we don't have a scheduler in the virtual cluster. And because we don't have a virtual scheduler in the virtual cluster, you cannot change anything. You are using it from the host. So right now, we are using the scheduler provided by Google. We don't even have any access to that one. Okay, we are out of time. Thank you for your attention. And if you have any further question, just check me and ask any questions. I can answer it after the talk. Thank you for your attention. And
let's give them a big hand, everybody.